Hello? Hello. Wow. What a great turnout. We're talking about this. Hello, everyone. Attention on me. No. What a great turnout. I think we need to start, looking at getting a bigger room for these kind of events. I just wanted to, hi, I'm Thorsteinn Friðriksson. I'm the founder and CEO of QuizUp, and welcome to the headquarters of QuizUp for those of you that haven't been here before. I just wanted to welcome you to our place and offer you some modest refreshments, beer and some snacks. I hope we have enough of them. This is, I think, a lot more people than we expected to show up, so that's always a good thing. So when you think of QuizUp, we've had a pretty wild ride for the last couple of years, but you really don't think of QuizUp like originally to be like a JavaScript company, and that's true. I mean, when Plain Vanilla started, we were a mobile-only company, actually an iOS-only company, just doing Objective-C, and then we started doing Android as well, and the latest client we've been doing is Windows Phone. But the fact of the matter is that actually JavaScript has become increasingly important to our work for the last year or so. And I think a couple of months ago, we actually opened up a new QuizUp.com that for the first time allowed people to play our game and enjoy our platform through their web browser and have a feature parity of being able to do pretty much everything you could do on a client on the web. And this is a pretty big step for us, especially because then QuizUp became truly cross-platform. You could actually play a game online on web against another person somewhere in the world using an Android or iOS or Windows Phone client. So JavaScript has actually become more and more increasingly important to QuizUp, and actually, especially now with the latest developments of React Native, we're seeing that the development of JavaScript is just, you know, unbelievably exciting, especially on the mobile front. And it so happens that because of the ease of deployment on the web, that JavaScript and the web has actually, you know, turned from being somewhat of an afterthought that it originally was, into being a very important testing ground for new features of QuizUp. And actually right now, most of our new features, like really big features that we will soon introduce to QuizUp, some of them are really, really exciting. I wish I could tell you more about them. But we're actually developing it online on the web first. So we're testing them with our great set of JavaScript talent here at QuizUp. So we can actually see how things work, what to adjust before we actually implement it into the client. And that's why JavaScript and all the web tools and everything around that has become an incredibly important part of QuizUp and this whole company. So, you know, maintaining a good JavaScript culture in Iceland is really important, of course, and I want to thank the organizers for setting this up. This is just really awesome to see how many people are here. And I'm not gonna say anything more because I can't really say anything that would add any value to what you know about what you know about JavaScript. But I want to hand the mic over to Kristján Ingi, who has been doing a fantastic job of organizing this. And I look forward to an amazing night with lots of cool things to hear. And I also want to note that we are hiring at QuizUp. We're actually doing some really awesome things in the next couple of months, both on JavaScript and also on clients. So if you have some interest in working on iOS, Android, JavaScript, data analysis, anything like that, I suspect some people have some knowledge in this, please don't hesitate to approach me or anyone else from QuizUp here, and we'll see if we can, you know, do something fun together. With that said, Kristján, here is the mic, and thank you all for coming and enjoy the beers and snacks. Thank you.
Hello, everyone, and welcome to the second JS Meetup this year. I'm really glad to see how many of you could make it today, and I'm really inspired to see how far we have come from. Yeah, in just 2 years, we have managed to be just a few people showing up every month or so, and now we are a strong community pulling in over 150 people to this meetup. It's amazing. Give yourself a good hand. Thorstedt gave me way too much credit, I think. We are a team that are doing all this, and it takes hard work and time to organize this all. And with me today are Kristján Oddsson and Axel Máni, and they have been really helpful in doing all this as well. So give them also a great hand. Lastly, I want to thank QuizUp for hosting us. We reached out to them a few weeks ago, and they just wanted to get us in and welcome all of you. It's amazing that they wanted to do that, and it describes the company, the team spirit in the company, that they are willing to just to facilitate us and do all this for us. Yeah. That's our sell, by the way. So yeah, we have been doing this for 2 years now, and we're really excited going forward to do more of this. The scene in San Francisco and New York and all those big cities, it's like thriving, but here in Iceland we're few, so we have to get together more often and try to build better community for ourselves. So I want to encourage you guys to reach out to us if you want to help out, or if you want to give a talk at the next meetup. Definitely reach out and help us build this community. Questions after the talk? No. Not the hard ones. So yeah, I'm not gonna have it any. Yeah, I'm not gonna talk more. I'm just gonna introduce Kristján Oddsson, who's gonna be our facilitator tonight, and I really hope everyone enjoys the evening. Thanks.
All right. I am going to introduce Guðmundur Már from DoHop, and he's going to talk to us about hack pros versus hack cons. Hackathon they did at DoHop, and I'll just set up. I'll tell a joke while you set up. No, I don't know any jokes. Somebody was asking how they could get involved. We have a Twitter, we have a GitHub that both have unfortunate names because JavaScript Iceland is like JS IS, which is dangerously close to IS. So don't look for that hashtag on Twitter. It's not cool. We'll talk more about that later, or come talk to us and we'll point you in the right direction. A joke, you say? No, I'm terrible at jokes. The GitHub, the name of it. We have an organization, and we have like. Are you ready? Actually. Yeah. Okay, then I won't. I'll talk about that later.
Christian, about that joke. All right. Woohoo! All right. Well, hello. My name is Guðmundur Már, and according to my fellow colleagues, I tell the worst puns in DoUp. So I'm here to talk about hacker pros versus hackathons, and the expectations, results, and lessons that we learned from hosting the first hackathon in DoUp. Well, so I'm more of a bad news first kind of guy. And when hosting a hackathon, there will be cons. I know the hackathon rules that we sent out said don't take the red pill, but that's for participants only. You actually never know what you're getting into when hosting a hackathon. Worst case being that you hold an on-site hackathon and no one shows up, or even worse, you'll have 100 results or solutions turned in, trillions of NPM packages and installations, and a really bad setup instructions, and 3 days to actually rank all the results. So, but basically, when holding a hackathon, expect mistakes, like having a countdown timer that doesn't take into account different time zones, which actually happened. These are kind of things that you can't really anticipate, but that's not really the role of a person who's actually hosting a hackathon. When hosting a hackathon, you're more like a referee in a competition or a competitive match. Your role is to make the decisions, and they won't all be right, but the better decisions you make, the happier the participants are going to be. So basically, here are a few of the decisions we had to make, when we were actually going to host it, how long it was going to be, where is it going to be, on-site, off-site, what do you get, like you as a participant, and then you as a company, of course, what materials are going to be available, the technologies, and what can you do as a participant, what are the rules and what's allowed. So we decided to have a hackathon in the middle of March. You can come in, my seat's there, first one there. So we decided to have it mid-March, have it 5 days. That felt kind of long enough in order for to have some interesting results, but not too long as to push people away. We decided to have it off-site and therefore anywhere, but actually just have it mostly in Iceland, like, post on groups in Iceland and such. But if actually foreigners wanted to take part, then they could, but it's easier to get everyone together in the end of the hackathon if you have everyone in just about the same country. Now, we decided to have prizes that were kind of relevant, the Oculus Rift and Raspberry Pi, and we gave full access to our flight search cache through an API, and decided to have teams, but the prizes would still stay the same. So if there are 5 people on the team, they'd still get this one prize. So it's better to actually be fewer and not 20 people, because then you're never going to see the prize. So, but the most important decision we actually made during the hackathon was our theme, because the theme is really crucial if you're going to gain any interest in people, and people are going to come and show up. The theme doesn't necessarily have to be about your material. In our case, it was. But Battle Hack, for example, held a hackathon where the hackers actually battled for a full-size, full-blown battle axe. So, you know, it's more something that people can talk about, and like, you know, hey, I'm going to win a big-ass battle axe. Like, you know, and that's much better than I got some money. Like, you know. But just remember, the theme itself needs to be very simple, clear, and not too restricting. Because if it's too restricting, you're just going to get the same results over and over again. Now, just the real side note, just to explain a little bit about why the flight cache is cool and what's interesting about it, like, and why it's difficult, really an airline-made problem. So having a cache of airline prices enables you to compare prices from a given destination to anywhere a year into the future almost instantly. We're currently using this for our apps, iOS and Android, and on the QuizUp/Go. But caching airline prices and getting airline prices is actually it's a immensely difficult problem, because the airlines themselves have made an environment in which they want to eat the cake and have it too, by milking as much as they can out of the passengers actually purchasing the ticket. Like a real live example would be an airline, United Airlines, going between Los Angeles and Chicago, has 43 different one-way economy prices. So those prices range from $109, $139, $149 to $1765, which is 16 times the cheapest fare. But they actually, when the bookings are strong, they close out the lowest level, and then if they keep strong, they close out the next level and next level and next level. When they slow down or someone cancels and such, they say, oh, nope, we're going to have to open up the lower level fares again. And so this process continuously happens until hours before your departure. So, and that's not even mentioning the problem about different residencies, blocking credit cards. They basically want all your money and as much as they can have for exactly the same seat. So, rant over. Now, but if you get through all this, like holding a hackathon, if you make decisions, if you make the good decisions, right choices, there is a lot of good stuff, and it actually comes as in form of your results. So in our case, we were immensely surprised. I thought there'd be like 2-3 people, you know, maybe. But we managed to have like this JavaScript thing that blew out of proportion. We had 100 people signed up, 10 working results turned in, 18 people behind those results. And out of the 18 people behind the results, there were actually, we were blown away. So we hired 4 and 2 full-time. And so, you know, everything worked out pretty well. And so I'm actually just want to show you a couple of the results. But since I don't have all the time in the world, you kind of want to get home and go to Ulfur and such. I hear. I'm just going to present 2 of them, but here are the 3 other winning solutions. They were the best algorithm that for global money laundering businesses. Feature that QuizUp is most likely to shamelessly steal and call its own, and the most nerdy README had references to Interstellar and, you know, how long it would take and different planet. You should read it later. It's actually available on doop.com/hackathon. Along with most of these solutions. There's one broken. I'll try and fix it. Just bug me. So live demo, obviously it's more fun because nothing can go wrong. Let's see. Oh my God, it actually worked pretty well. Okay, so I'm gonna start off with, this was the runner-up solution. Discover the World, they called it. This solution was by Arnar Þór Sveinsson, Axel Máni Gíslason, Guðmundur Egill Bergsteinsson, Sólberg Bjarki Valdimarsson, and Sölvi Logason. So 5 people. They didn't take my advice to be few and take the prize, but you know, basically the groups were between 1 and 3 people. All the other groups, these were an exception. But we really like the cover. They have shining stars in the background there, just an extra little fluff that we really liked. There's, let's see. So you basically need to start out with your airport or your starting point, and we'll take Reykjavik since we're all here. And they give us a month into the future and basically create your journey. The algorithm works. I'll show you later, but basically there's they showed us here. We go on the 24th to Barcelona, then Turin, Italy, Rome, Budapest. Damn. London, and then back, and you can get that for $556. So it was very impressive, and it was very nice. And actually, if you lengthen the time you have, let's say I'm gonna take a summer vacation after this talk until the 20th of October, and then you can create the journey, and you can see the algorithm actually leaves from Iceland, and then it tries to find the cheapest place, and then if it can't get all the way, it backtracks. So and finally, when it gets all the way in the cheapest way, it presents to you all the results here on the right side. So this, you could go to significantly more amount of places there. You can go to 1, 2, 3, 4, 5. I'll just say Barcelona, Turin, Rome, Budapest. You're counting Axel. Budapest, Helsinki, Frankfurt am Main, Faro, London, Edinburgh, Copenhagen, New York, and then back for $1,700. So, well, okay. It's your solution, fine. There's so, and then they had the attractions and street view into the place itself, and yeah, it was just basically really cool. He's still kind of pissed that he lost, but I wasn't the judge. But yeah, that's kind of it. You give them a round of applause for that. So the winning solution was called World Trip, and it was first prize had Adam Norðfjörð Viðarsson and Jón Þór Kristjánsson. They actually present you with let's see, with this awesome pop-up. Now you start from Iceland. You can see Iceland is a little bit more dark blue, and then all the light blue countries there are the available countries, and all the dark blue ones are non-available as direct flight. So if I start my trip, I'm love to go to France, since apparently React Native or React was there, but I didn't get to go. Now they present you with find a hotel, find a hostel, and then they show you your way over, and this part of the booking pops up on the left side from Reykjavik, and it costs 10,000 kroner, and you can book it later if you want. So I'll just keep on going. If I go to Germany, like pick that flight, 5,000 kroner, and then I go to Turkey, and yeah, I'm pretty happy about that. Then if I can't really seem to find my country, let's say I want to go to Oman, it's right there. But Romania actually, like has Oman in the name. But and then let's say I wanted to go find vodka, that would be there, and then I really want to find Luxembourg, and it's gonna be. It's a bad pixel resolutions. It's 1 pixel right there. So don't go to Luxembourg apparently. But yeah, that's just about it, and you can give a round of applause to them, please. So if you guys, since I know not all of you saw the very well, you can go on to duop.com/hackathon and then press winners, and you'll be able to press in the blue links the winning solutions and the ones that I didn't get to show you. So you can do that when you come home or whatever, and just bug me if they're not up and broken. But yes, back to the slideshow. So yeah, basically, if you have any questions, let me know. But I just want to say thank you. Yeah. Yeah. Anyone have any questions regarding further rants on airlines hackathon? The hackathon next year or something. Well, if I there was one disappointment that I was kind of, I want to have, if I hold another hackathon next year or Duop holds another hackathon next year, I'd really like more girls and women to participate in the hackathon, since unfortunately the there was one girl who turned in the solution out of 18, and then it was we'd like to bring that a little bit up. So please, next year, if you'd like. But yeah, thank you.
Alrighty. I was gonna introduce next one is Guðmundur or Gundi from Heroku. See somewhere around? There you are. Are you still writing your presentation? Oh. And I'll continue with the jokes while he sets up. No, our GitHub, I looked it up. It's JSIS, and it's where we organize all our stuff. We have like different repos for the monthly meetup, and then we also have a weekly meetup at Kexhostel. If you ever want to go see us there, it's really fun. There's no pressure. You just show up and just talk about JavaScript. You just let me know. I'll rant while you set up. Yeah, and then the Twitter. Kristján opened up a Twitter. I don't know what it is yet, but he tells me it's at Reykjavik, like RVKJS. And we'll post like pictures from this and like live stream links. I believe we're live streaming this on YouTube right now, which is a little bit terrifying. Yeah. Is anybody going to Úlfur leather? It's why I'm wearing these shoes. It's my rap concert shoes. Are you gonna be ready soon?
Yeah, working on it.
Yeah. I thought I could stretch this out to be longer.
Keep talking.
Yeah, but anybody can like open up an issue and like, I want this person to speak about this cool thing he showed me the other day. I did that to Axel the other day, and he's gonna speak next time. There's like a sea of people here. I can't find him. Oh, he's out there. He's going to talk about a really cool thing next month. You ready?
Yeah,
All right.
I'm not gonna torture you anymore. So hi, I'm Guðmundur Bjarni. I work for Heroku. I'm remote guy, as we call it. So I'm remote from Copenhagen, Denmark. About half the staff is actually remote. I'm on a team called Development Experience, and we basically build features that make your lives more awesome. Speak up. Hello. Yep. Hello, hello, hello. Is this better? All right. We work on features like we built a Dropbox integration, which is mainly for designers and people that don't know so much about Git. We built then the GitHub integration, so you can automatically deploy. By the way, who knows what Heroku is? Okay. If you don't know what it is, ask any of the other people around you later on. It allows you to automatically deploy whenever CI passes on GitHub and stuff like that. And I was actually going to showcase a feature of that, but Christian asked me to do something more nerdy and low level. So the feature I wanted to show is something called review apps. So whenever you open a pull request on GitHub, it'll actually spawn up a new app and databases and everything and push that pull request to that app. And then when you merge it, it closes everything down. It's kind of magical. But yep, so I'm going to talk about logs instead. If you have any questions about Heroku or working remotely or something, then please find me afterwards. If you have questions around the stuff I'm talking about, please stop and interrupt me and ask away. And before we get going, I'd like to thank the QuizUp folks for hosting me here. I've been at the office for a week working here, and they've been awesome. So if you like to work here, go and do apply. They're highly recommended. So who knows this? 12-factor apps. Okay, so this is like 12 steps of how to make your apps awesome on the cloud. So if you want them to be scalable and all that stuff and easily manageable, then like this is a manifesto for how to do that. And it's actually written by the guy that started Heroku. And logging as data is one of those steps. So I could rant on this for ages, but I'm just going to do logging because that was the thing I was blown away by when I started at Heroku. So the first thing I kind of wanted to go through is like, this is a normal HTTP request when you use Apache. It has a lot of stuff in it, but it doesn't have any context about what this stuff is. So looking at it, you can kind of guess at what some of this is, like 30, what is that? But like, I know it's the length of the request, but it's kind of hard. Same thing about this one. This is from Ruby and Rails. This is like the default stuff. It has some more stuff, some like is missing, but it's really hard to parse what it actually is. So the logging as data concept is basically logging everything to standard out rather than to files like people tend to do. So you can view it in the console. So when you're developing stuff, you can actually see what's going on rather than having to open a file and see what's happening in there. And it's easy to pipe it somewhere else. So if you actually want to put it into a file, it's easy to do. If you want to send it to some logging service, then that's easy to do as well. And also, you don't need to know anything about log rotations in your parsing stuff. The logging as data as we do it, this is not in a 12-factor thing. We log everything as key value pairs. So some key equals to some value. If it's a Boolean, we just skip the value. If the Boolean value is false, we just skip the key as well. If it's a string, then with spaces, we put quotes around it. Same goes for timestamps. They have spaces, so they have the quotation marks. And to make date parsing super simple, it's just ISO standards. So if you do this stuff, then magic will begin to happen. Because what this actually means is that like a simple log entry is going to be something parsable. It keeps all the context. So you can see this is like hello, message is hello world, and the timestamp is like right now, or this is yesterday. This is kind of cool. The other thing we do is like whenever you make a request to Heroku, the first thing we do is assign a UUID to it. That's going to make things really cool because you can start like searching for that UUID and you can find everything that happened within that one request. So that's something I highly recommend. And if you make calls from one service to another, we actually pass that request ID on and we tack on a new one. So you can always search by the kind of bigger request ID, and then scope down if you want to see relating to one service. And the cool thing about this is that if a user sees an error, something went wrong, like please try again, but if it doesn't work, then send us this ID. So we get a support ticket with the ID of like something broke. We can actually go and search for whatever happened during that one request. So it makes support way easier. So a typical web request is going to look something like this. It's going to contain like which app this is, the request ID, which is this long, disgusting thing there, and then that this is a web request when it starts, which path it hit, and then when it finishes, it's going to contain like at finish, the status of the request, and then also how long it took, which is kind of cool. Another thing we do is something called log context. So whenever you have a request, for example, oh, actually, I have an example of that. Haha. Sorry, this is Ruby, and it's just because I've been doing Ruby for a couple of years now. I've done a ton of JavaScript, but never this stuff. And we have a lot of libraries to help out with this stuff. And there are some for JavaScript. I don't know how to use them. I haven't touched them. But this is like in Ruby. So you have a method to authenticate a user using a request. And here in this example, like if the authentication is successful, we add the user's email and the user ID to the log context. So everything that happens after that point is going to contain like this user did this and that. So you can tack on these like different things to make things easier to debug. And then there's this log line that says like log authenticated true. And when you run that stuff, there you go. You can see here that like it prints out this authenticated. Then it has like my email address and my user ID. This is just a random UUID. So, and it contains that like between those two. So with that one request, if I look up like this request ID, I'll get all the stuff. So this is super helpful. Also, like you can log function calls. So if you do something that takes a while to run or something, we have this helper to, you can add like this thing here and pass it a block. Then when you actually, does anyone know what this does? Can someone guess? Sorry? It's to calculate factorial in Ruby. It's beautiful. Go Ruby. So this will actually output this. So when you enter the block, it says calculate at start. When you exit, it said calculate at finish, and then the time it took. And this is like, you can see here, it also outputs like the signature that matched this thing and like the number you passed in. So this stuff becomes super valuable. I'm not joking. It's the best. Also, API calls. Those are expensive operations. And we actually do this crazy thing. Whenever you use an API client of some sort, we inject these logging helpers into them. So if you make an API request to the Heroku API within Heroku, like our services, it'll log like when it began, when it ended. Same if you do log request or API requests to GitHub or Dropbox or something, everything is logged. So here's an example. I actually ran an app that contacts the Heroku API, and you can see that like this is the HTTP library I'm using. It's called XCon, and we inject this stuff in there. And it says like this is the beginning of the request. It's contacting this host at this path. It's using GET, and XCon has this awesome feature. You can tell it which response codes to expect. So you pass in that thing here, and it says it's at start. And when it finishes, it says like the response was 200. If it was something else, it would have blown up and logged like an exception. And then we also like the miscellaneous stuff that we do is adding like, for example, what the rate limit is. And that's really helpful if you see like, oh, errors started happening all of a sudden, then it's easy to see if like the rate limits hit 0. Then that's the thing to look for. Miscellaneous information, as I mentioned, that's like if errors occur, log out whatever you have to help out. For example, also in worker queues, you can log out if you skip a retry for whatever reason. And it's going to be immensely valuable when you're debugging later, because what we use this for is debugging live systems, like huge SOA systems that are otherwise impossible to debug. And this format in this thing, it's something we call log font. A colleague of mine called Brunter, he actually wrote a blog post about this. So I highly recommend that. His name is Icelandic. He's not Icelandic, he's Canadian, but he's one of the best Icelandingas. So, or his grandpa. So his blog is awesome. He has a lot of stuff about like writing these kind of systems. So I wanted to show an example of like how you can put all of this together. Today I was testing something out and deploying it, and I broke the service that I was deploying. It's like behind feature flags and stuff, so nothing went down. And the first step to doing that is using, like Heroku has this thing called log brain. So all your logs, you can tell it to put it somewhere. And I told it to, it's set up automatically actually for it to Splunk, which is a log searching cluster. It's crazy expensive. So if you got lots of money to burn, then please use that. Otherwise, you can use Papertrail or log entries or something else. You can use Elasticsearch as well. So I deployed this change, and I tried hitting an API request on it, and I got a 500 back. And I was like, oh shit, like I had pushed this to production, so I had to do a rollback. I just knew like this is logging everything, so I don't need to try to figure out what's going on while the system is running now. So I just did a rollback and captured the request ID that I got with it. What are you doing, man? Yeah, so I copied the request ID into Splunk. So this is Splunk. I've scrubbed out the things that you can't see. There are numbers everywhere in this. So I paste that into here, and I can see that like 38 events, like 38 log lines happened relating to this thing in this time frame here. Oh, that's actually that bar, but the entire time frame is timestamps, you know? And this is like, usually it's more than 38. Usually it's like in the hundreds. So I got a 500, and you can see down here, it says like error expected 200, actual 401 unauthorized. So it's like, huh, I wonder what that is. This is like a service that's calling to a couple of different services. And I kind of suspected this was coming from API because that's doing all the authentication. So you can see there's like a key we have called app equals to something. I showed that earlier. So if I go ahead and click that, I get this thing. So it shows me like there are 26 events on the API, 7 on this thing called Pipa. So I name all my projects Icelandic names. So all the Americans, they have a hard time with that, especially Kolkrabi. They love it. That's a GitHub integration, by the way. So I kind of knew this was an API, so I clicked that. That brings me to this thing, and I've scrolled down a bit, and I can see here at the top, like unauthorized invalid credentials provided. So that's the error that's occurring. And that also tells me there's something wrong with the token I passed in. So if I look a bit further down, it says like authorization length 6. No token is 6 characters. So I only passed in like bare space and then no token. So I forgot to pass the token to the client. And this is something that's like, you're not going to run a debugger on live systems. That's just like impossible. So this is actually a really nice way to do that. And we really log a ton of stuff out. Another cool thing you can do with this is you can actually generate metrics from these logs. So we do this thing, it's kind of like statsd, if you know that. If you say like count hash some key and then a value, a numeric, it can do these counter things. And then measurements, that's, for example, if you want to track time or something like that, you can say measure hash key and some value, seconds or something. And you can see where I've deleted things of this. I can show you the numbers, but this is from the GitHub integration, and we react to a lot of events that happen regarding repositories that we've connected. And we are mostly concerned about 2 of them. One of them is like a push event, something got pushed, and then a commit status, which is the CI integration stuff. And you can see like the untracked, that's all the other stuff. We basically receive all the events connected to the repositories. You can see that's like majority of it, but down here you can see like the actual push stuff and all that. And these are the counter log entries. And then if you do the measure thing, it actually generates like the actual measurements, and then it calculates the median and also the 95 percentiles and the 99 percentiles. So you can do a lot of cool stuff with this. And the crazy stuff we do is we actually do alerts from metrics from logs. So most of our alerting on Heroku is pulled from these metrics that we have in Librado. And we have this project called Empire, which turns Librado metrics into HTTP 200s or non-200s. So you can say something like, if you call to your Empire, this is open source. So if you guys want to use this, it supports Graphite and Librado, and it's fairly easy to add something else. You can say, like call this umpire thing I have running on Heroku, of course, and check that this metric here, which is like number of 500 requests, if it's more than 5 in the last minute, then alert me. And we hooked that up to PagerDuty, so it knows how to page us. And we have this, we built a ton of systems to integrate all sorts of crazy things. So this is a tool that we built like on top of all these metrics on logs and all that stuff from the thing that actually does the paging. So we have historical records of when people got paged. So this is for my team in the first week of this month. And you can see like we got one of ours critical page, which was like actually went to our phone. So it knows about which time zones you're in and stuff like that. And you can see that it started by paging me, and I didn't reply within 5 minutes, so it paged Andy in the UK. And then like all these things are also key value pairs. So everything we do is key value for the win. So yeah, so this is my selling keynote for using key value pairs in log entries. You should do it. It's a really, I mean, it's a really cheap way to get a lot of metrics into your systems and know what's happening on live systems. The places I worked, it's usually the only things we log out or the requests coming in. And in Java systems, you just log everything and it's totally useless. So yeah, if you have any questions. Yeah. Yeah, so this is actually, anyone can do this. If you use like any of these like logging machines like Splunk or Elasticsearch and Logstash and all that, they support all of this. So it's not internal to Heroku. Yeah. Yeah, so the question was whether this was internal to Heroku, whether this was something we only use. Yeah. Anything else? Thanks.
Awesome. Next up is David from Aranja. And his talk is called Building an API for Icelandic. This is probably the only one that I don't know. I have no clue what's it about. And I'm really interested to seeing what he's going to show us. Yes. I've run out of things to talk about, actually. I wanted to reiterate about our weekly meetups. They are really cool. We, and Axel wants me to shush the people in the back that talk while the talks are going on. Yeah, our weekly meetups are kind of cool. Hey, shh. All right. Our weekly meetups are kind of cool. We meet at Kex. We drink beer or not and have food and just talk about random stuff. It's a great way to see what other people are doing. It's every Wednesday at like 7:30. rvkjs.com is the site you can go to, and it has all the info and stuff like that. All right.
Hello. First off, 2 apologies. Firstly, that my name is not Guðmundur. I've really broken the streak there. And secondly, I didn't know that my talk would be following a talk on Heroku. So some of what I'm going to say might seem slightly snarky. So let's see how it goes. Okay, building an API for Icelandic. Why on earth would you do such a thing? As you can probably tell, I'm not from around here. I moved to Iceland in March this year. And along with many other challenges like the weather, I've started trying to learn to speak Icelandic. And I'm not going to lie, it's pretty tough. And one day I was going through one of these terrible grammar books, and it had some exercise where you had to match the adjective with the noun. You had to write like a yellow banana and the blue sky. And I was going through this and I was thinking, this is impossible. This is there's so many combinations of all these things, and this is the job for a computer. And then I started thinking, maybe I could just write a program to solve all my problems. So This is how we got started, building an API for Icelandic. So how do we build an API for Icelandic? Right, we're going to need some data on Icelandic. Fortunately, it turns out that there's actually a great data set on Icelandic declensions. How many people are aware of the database of modern Icelandic inflection? Yeah, good. Okay, obviously most of you are better at Icelandic than me because this thing is completely invaluable. I don't know how anyone learned to speak Icelandic before this. Maybe they didn't. I've never actually seen any evidence. Okay, so what is in this database? They actually provide the data set open source, which is really nice. And it looks kind of like this. Okay, so you have what's called a head word, which is like a word with related words. So we'll take tala. It has some ID. SO means it's a verb. ALM means it's from the category of everyday words. And then talar is the specific form of tala that we're interested in this entry. And then it has this crazy string at the end. This is grammar tags. So it tells us that it's active voice, it's second person. Maybe all this is nonsense to you, but this is what us foreigners have to think about when we speak Icelandic. And there are many of these tags because, of course, Icelandic grammar is much more complex than English. So there are just over 6 million of these in the data set. You can see why we're using computers for this. Okay, so we've got 6 million Icelandic words. What are we going to do with them? We're going to need a database. So it seems pretty straightforward. We've only got one type of data. It only has 6 columns. They're all exactly the same form. The database can even be read-only. Like I know that they do make up new Icelandic words, but they don't get into bin that often. So for our purposes, the database can be read-only. And we'll just need to create a couple of indexes on the columns. So pretty straightforward. This sounds like the perfect kind of thing for any SQL database. We'll pick something simple, MySQL, Postgres. But who wants to create a hobby project that uses Postgres? Not me. So how many people have heard of LevelDB? Cool, okay. So LevelDB is a project from Google. It's actually the backing store for IndexedDB, which is the new SQL-like database that's coming to the browser. So you'll definitely get to use it at some point. I think it's already implemented in Chrome and Firefox. It's also used in Minecraft Pocket Edition, so it must be perfect, right? So what do they say? It's a lightweight single-purpose library for persistence with bindings to many platforms, says the marketing site. What does that mean? Okay, it's a key value store. It's NoSQL, if you like. The defining feature is that the keys are sorted lexicographically, which is what most people call alphabetically. So they're ordered by their Unicode value, essentially. And it uses Google's snappy compression algorithm, which is a compression algorithm which is optimized for speedy retrieval rather than maximum compression. But it's quite nice. So I've got all these records. I want to put them in the database. If I'm going to get them back out again, I need to have some key that I can look them up by. And my thought process goes like this. Okay, we need to pick something that's unique about each of these. It looks like we've got some kind of ID here, but unfortunately, this represents many words. So this represents everything in this verb that's related to tala, which turns out to be around 120 entries. So no good as an ID. And then I'm thinking, oh, there must be some combination of this head word in white and then the grammar tags that must make it unique. But eventually I just decided this is a really good primary key. I will just use the whole entry as the key. And it turns out in a key value store, you don't actually have to have a value. So we're just getting started. Okay. Creating indexes. So how do you create indexes in key value stores? Well, normally most of them just say, oh, you can't have indexes. Maybe you have a primary key if you use any of the hosted ones. This is actually quite similar to Google's big table, but that's quite restricted on what you can index. So we're going to create our own indexes. And remember I said that the defining feature of this is that it's sorted. It's like a sorted dictionary, if you like. So what we're going to do is we're going to pick the fields that we want to index on, and we're going to put them on the front of the entry. So this means that when I go to look up this word form talar. The database reader can just jump straight to T. It's a really fast read, can read all the entries that start with talar, and then we can get some really quick results. And then the same for the numbers. We can look up those by their, I guess they come out pretty ordered, yeah. So this is what our database looks like. Each entry inserted twice with the fields that we want to index at the front, and then some kind of, we just have a separator here so that we know when the rest of the record begins. So cool, we've got a database. The original CSV file, 284 meg. Our database, 171 meg, thanks to compression. So good start, maybe. Okay. I'm actually going to demonstrate some JavaScript. I thought about writing it in the Icelandic programming language. I thought that would be a good programming language to build an Icelandic API, but yeah, not a good idea. Okay. How many people here have built an API using Express on Node before? Cool. And how many people are using ES6 day-to-day in their JavaScript programming? Okay, not so many. Okay. I thought it would be nice if I just give you a really quick tour, kind of top to bottom of what this looks like. I think it's gone to a point now where it's really nice to write these Express APIs in ES6. So, okay, so just jumping in straight at the starting point. Is this readable? Shall I make it bigger? Bigger? We'll see how much actually fits on the screen. Okay. So the nicest way I found to use ES6 today, whilst it's not all supported in Node, even under the flags, is to use Babel. And Babel is a transpiler. It compiles JavaScript of tomorrow into JavaScript of today. So this is, in fact, the only file in this project which is in ES5, or regular JavaScript. And we just use the normal Node.js require system to call Babel register, which just hooks up a load of horrible things, probably, which sets off the transpiler. And then we can just jump straight into the server, which is all ES6 from here on. Another slight warning, this is when I was going through my no semicolons phase. So if that upsets you, I'm really sorry. Okay, so we can use the fancy new ES6 module import syntax. So import express from express, really nice. Load in some middlewares, so we need cause. This middleware response time just adds a header that tells you how long it took to make the response. These are our roots. I'll come to those in a sec. Then we just boot up the app, add the middlewares, add the roots, and set the server off. Like, it couldn't be simpler. So let's jump into the first route, which I'm going to show you, which is a declensions route. And we'll look at this method here. So when we get a request /find/some word, we're going to jump into the declensions controller. We have a method here called find. Pretty basic. It's just going to go to our database and look up the word. And let's see how we do that. Okay, so now we've already hit the bottom level of this. We're going to load up our level DB here. There's a npm package called level, which is kind of node bindings for level DB, and then there are other packages for if you want to access database from other systems. Okay, so to open the level database, you just give it a directory. Level DB is just files on disk. So it's nice and simple. You just point it at a directory, and off you go. And so how do we search this thing? So the operators that you have are kind of, because it's ordered, you have greater than and less than. So we're just going to search between the thing that we're interested in, and then the thing that we're interested in plus some high Unicode value. So basically the last possible entry that it could be, which in Unicode happens to be this guy. Cool. And then you can say, like, stop after you get so many records. And you can see here that the method is called create key stream. Remember, there's nothing stored in the values, so we're only interested in retrieving the keys. And this returns a stream. I have a really hard time working with streams. They just don't work in my brain at all. And there's, I mean, the Express itself supports streaming responses. So you could, if you wanted, just take your results from your database, stream them right back to the client. If you have some big responses, that might be really nice. But I decided that I wanted to have my API response, I wanted to have the total number of entries that are going to be returned. And the only way you can do that is to buffer the whole response. And then at the end, you can see how many results you got, add that on, send it back. Otherwise, when you try and add that, you've already started sending the response, it's gone. So how do we turn a stream into a promise? Is everyone using promises to write their async JavaScript? Put your hand up if you're using promises. Okay, see me after. No, I think promises solve so many problems, and I would recommend them without reservation. So what we're going to do here, if you haven't seen promises before, this is going to be a bit crazy, but a promise takes two functions, resolve and reject, and they're kind of like two callbacks, which we called whether it works or whether it doesn't work. And how we adapt this to the stream is if the stream errors, we're going to call reject, and otherwise we're going to pipe the stream into something that kind of just buffers up everything, and then once it's finished, it's going to call resolve. So now we just have a promise that resolves with all the entries that we're interested in. So then we just take these results, which are still in CSV format, and we map them using some map to some kind of nice JSON format. And that is pretty much our request. We start going back up, and we get back to the router. And then this is kind of, you can see that this returns a promise, because then we call then, and you can just chain these thens if you're used to any chaining API like jQuery or anything. It's really nice. You can just keep adding more and more of these on as you want to do more processing of the results. It's really clean. So we'll pass these results to some filter, which I'll show you. And then we pass the results of that to some formatter that prepares the response to send back to the client. And then finally, we pass the results of both of those things to res, which is Node's way of sending you back a response to the client. So that's kind of a quick tour of this. We take a request, it goes to LevelDB finds some relevant entries, and we send them back. So what kind of results can we get? This is really small. Okay, so this is api.tala.is, which is the name of the project. And you can see I'm going to search for Tala, and it's going to say there are 6 entries that match this exactly. Obviously, Tala means more than one thing, which is like one of the massive frustrations of doing this kind of project. So I've got a little entry up here that tells us that we found some nouns and we found a verb. So say we're interested in this verb, we can append word class equals SO. So now we've only got 4 entries and we've only got verbs. So this is kind of how the API works. You can add these filters to kind of fine tune the information you want to get back from the API. Okay. So have an API, have a database. We're going to deploy it to Heroku. No, I'm just kidding. We're going to use Docker. Why would we use Docker? How many people have used Docker here? Nice, that's really cool. How many people are using Docker in production today? People are less confident about that one, okay. If you're not sure why you should use Docker, basically, it allows you to package up your apps with the environment that they need to execute in. So dependencies, environment variables, all these things. And it allows you to run multiple apps on the same server without conflicts. And this is kind of how I got into Docker and containerization in general. I had these kind of hobby projects, and they would be quite hit and miss, and then one week I'd do something, and next week I'd do something else, and I just wanted to have one server where I could just host all these things. I didn't want to worry about like, what port was that one running on, and did I set this environment here, and I just want them to work. And correct me if I'm wrong, I think this is basically how Heroku manages to host lots of apps on the same infrastructure. You containerize the app, and then it has its own sandbox that executes in. It's really nice. So just quickly, there are two approaches, I think, to using Docker. I didn't know that this was going to have a Heroku talk. So I've called this the Heroku approach. Basically, you're using git push as a deployment mechanism. You push your entire kind of repository into a container, and then the app builds inside the container. And so this can be really nice. Like, one thing that I really like about this approach is you can't deploy anything if it's not checked in. And I think that is a good thing. One downside to this approach, which is why I'm not using this approach for this project, is say you write some kind of front-end thing that uses React or Ember CLI or whatever, and that depends on NPM. You have some NPM dependencies. So you have to have Node installed in your container, and you have all this stuff that you don't actually need this to run the app. Like, you're building a static website, and you probably want to run a static website using a web server that's more dedicated to this, lower memory usage, something like Nginx or whatever you like using, Apache. But now your container is full of NPM, and you kind of haven't managed to, there are obviously some nice things, but you haven't managed to kind of build a minimal container for what you actually wanted to run. So I'll talk about one other approach, which is what I'm using here, which I call kind of an app engine approach, which is like rsync. So it's just files. You just copy the files, the build artifacts, into the container. So you build your app locally, and this, I think, is the downside of this. But then you put the built files into the container, and off you go. You'd only need kind of the minimal things that you need in the container to get going. So how do we build a Docker container? Well, we use a Docker file. And they're really simple. So for our database, we're going to build a container that exports a volume, which is like a kind of a drive, if you like, a disk volume. So this says, okay, we're going to start from, every Docker file has from at the start. It says, what's the base image? Where do I start from? We're going to start from BusyBox, which is a minimal Linux container. We're going to create a volume called code/db, which is going to be available to other containers. We're going to add our database in here, and then every Docker file has to have a command, but we don't really care about this. We just got data in this one, so we'll just run any old something. Okay, so the API I've just showed you, how are we going to Dockerize this? So one of the really nice things about Docker is that you don't have to be a ninja at building these server environments and configuring everything. You can just use someone else's. So I wanted a Docker file that would support running a Node application, but also it needs to be able to build native extensions. So the level DB is a native thing. It needs to build specifically for the platform. Like if I just checked in the binary that built on my Mac, it wouldn't run on Linux. So we need to build it inside the container. Okay, so workdir says this is our current working directory. We're going to add our code for our API. I'm going to run a command, run npm install. That's going to install the dependencies, and it's going to build our level DB bindings. Expose says this app needs to be contactable from the outside world on this port. So 8000, we're going to put it in there. And then command again. Command is like, what is the entry point for this container? npm start. We've got a start script in there. And then one more example, just to illustrate the difference that I was talking about in this approach, is say we have an Ember app that we want to deploy. Well, we're going to start from the base image Nginx, which is just, I think it's just raw Ubuntu with Nginx installed. And then we're just going to copy in our Nginx config file, and we're going to copy in our this directory, which is our built app. It's just static HTML, JavaScript images. There's no server component to this. So these are kind of 3 different flavors of Ember app. What are we going to do with all these containers that we just made? Okay, we're going to host them on a thing called Totem, which is where it gets interesting. So I'm going to show you my, is this kind of legible? service dashboard for my Tutum account. So, okay, we've got I'll just read them out. We've got the API is the first one, got the data container, got the front end, which is an Ember app, and then we've got a fourth one, which is hard proxy, which is high availability proxy, which is a reverse proxy, which I'll talk about in a sec. So in the API, yeah, okay, so if we look in the volumes for the API, we can see that it has one volume from other services. So it has mounted the kind of disk image, if you like, of the database. Why would you do this? This seems really hard. Basically, it means that if you use a database like this, you can recycle your API as many times as you like. You can deploy it, and this data is all persisted outside of that container. These containers only live for the life cycle of the app. So once the app finishes running, the container is discarded, and then you deploy a fresh one with your new program. So if you want to persist data, exactly the same as on Heroku, that data has to live outside of your application. Cool. So yeah, to do this, we use the Docker command line. We just run build, that just runs our Docker file. We give it a tag, which is the tag that it's going to have in the registry. So Docker has a registry similar to NPM. Then we push it up to the registry, and then we're going to call a webhook to say that there's a new version available. And it's pretty much as simple as that. Demo. Dun, dun. So now we have a brilliant API. What are we going to do with our Icelandic API? So this is one front end that I've built for it to help me learn Icelandic. And hopefully you guys will think of more interesting things that you can do with this data set, because it is a fantastic data set. So just to quickly show you what this is, basically it has a couple of different modes, but it can help you conjugate verbs. So if you write futala, it will say you meant futalar, and it will give you a suggestion of the past tense as well, which is nice. So obviously we can never know what language my keyboard's going to be in, so nope. Okay. And you can just change the pronoun here, and the thinking behind this is that normally when you go on bin, you want to look something up, you get back like all the results. So you look up the verb tala, you get 120 forms of the verb, and it's kind of overwhelming. So I wanted to come up with a little way to just look up exactly what I was looking for really fast. So yeah, it can help you out with those verbs that are what you could strong verbs / really hard verbs. So verbs that are more irregular, you can look them up easily. Any pronoun. And then there's also...
What if you would write like a pronoun and then the wrong, like when you said you wrote Tala.
Yeah.
But what if you would write Tala?
So you can, this is the nice thing, is that if you know any form of that verb, then it will find the correct one for you.
Any.
Yeah, so for example here, I've written han segja, and it's found han segir. So this will take you, basically, it looks up that verb, it finds all the forms of that verb, and then filters back down to which ones match han. And I've just set up some filter that says han requires third person singular. So it's pretty simple. Another problem is those pesky prepositions. So for example, you cannot say frá ég in Icelandic for reasons best known only to Icelanders. You have to say frá mér or frá okkur. If these examples are wrong, I'm really sorry.
No, I'm just saying you wouldn't say from I. Either.
Yeah. Okay. From a horse. There you go.
Yeah.
You could say this. You could say till han. It would say, okay, till directs the genitive, so you need till hans, etc., etc. So this is one idea that I'm kind of playing with at the moment. You basically give it a word that describes the context that you're in, and then the word that you're wondering about, and it will try and match up a result. Sadly, this has already fallen flat on its face because with is both a pronoun and a preposition. So some work to be done still, but yeah, I just wanted to share that with you guys. I hope that's kind of interesting. The code is all open source. It's on github.com/davidblurton/Tala-API is what I've showed you today. You can find the rest of the code on there as well. These slides, if you're interested in this Docker stuff or LevelDB, slides.com/davidblurton/Tala. And then the API is hosted at api.tala.is. So go crazy. Thank you very much.
All right. What? Yeah, are there any questions for David? Hi.
I made a quiz from you, but where did you get all those words? What are
Yeah, the link, yeah. Sorry, the question was, I might have missed it, where did you get all these Icelandic words from? It's from a data set provided by the database of modern Icelandic inflections. I can't remember the website. This is one of the problems. It has some ridiculous website that is only typable if you're Icelandic already. I will get the link for you. Yeah. Yeah, exactly. There you go. bin.arnarstofnun.is. Yeah. Okay. Apologies.
Some more questions?
Yeah. Yeah.
Is the example you're working on also available on GitHub or
Yeah.
anywhere else?
So the front end that I just demoed is also on GitHub. Same URL, Tala front end. And they're all in the Docker registry, which is public as well, if you want to just download the containers and run them yourself. Cool. Any other questions, just come and find me at the end. I'm happy to talk about any of this stuff. I don't speak very good Icelandic. Yeah.
All right, awesome. Let's give him a hand. Now we come to our final talk. Arnar from QuizUp is going to talk about React and Flux. And I'm really excited about this one. While he gets set up, do you guys want to come like sit over here? Like you can't see any of the stuff. Go like take my seat. I'll go somewhere else. And I'm not going to do any rant this time. I'm just going to say this is a really good time to go get beers because it's super warm in here. I'm sitting by the window and I'm boiling live. So we'll start in like 2 minutes. Hello, 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 hello. Fuck. We're gonna start again, and like when everybody's starting to sit back down. I guess people are eating. Okay, we're gonna go start again. So just find your seat, and this is gonna be awesome.
I got a comment from the people behind there to speak up.
Speak up.
Or like turn it up.
I'll do my best. All right. Hi, my name is Arnar. I work here as a developer at QuizUp in Team Platform. We've been working with some awesome technology for the last year. We've been dabbling in React, Flux, and ES6. So today I'm going to talk about how we created the QuizUp. Where's my mouse? There it is. Today I'm going to talk about how we created QuizUp gameplay on the web using the Flux architecture. And the main focus is going to be how we use the stores to manage data. Team Platform takes care of internal tools here at QuizUp along with some services, but our main project is QuizUp.com. So here we have a screenshot of the web. If you've used it, you'll know it's a pretty complex product and we're working with a lot of data. The web is written in React, so all of the data is stored client-side. As you can see, we have chat, feed, we have discover people section, topic pages, profile pages, and more. And of course, you're able to play the game on the web as well. So we need to store all of this data somewhere, and it has to be simple. So I'll use how we implemented the gameplay as an example of how we manage data using Flux. Playing the game QuizUp is simple. You'll just have to answer a question and wait for the opponent to answer. But keeping track of everything that can happen in a single game is extremely complex. This is a flowchart, which is vastly simplified, of one single question during a game. So the red dots are states that can occur, and the red text beside them is some of the data that needs to be updated in each state. The black text and arrows are protocol level actions, like answering a question or surrendering the game. And these are only the client-side states. These do not include all communication that need to take place between the server and the browser and other clients. So this is probably a bit more complex than many of you had imagined. And this is where Flux comes in handy. Using the stores and unidirectional data flow reduces this complexity a lot. And keeping track of the data and communication is way easier than we thought. Flux works like this. An action comes into the system. For example, the server tells us your opponent answered this question. The dispatcher makes sure that the action gets sent to the stores and are handled accordingly. The store is the data layer. It updates on each action. And then finally, when the store has updated its data, it emits a change and tells the view to re-render. The view can also send a new action back into the system, for example, when you click an answer. The dispatcher makes sure that the effects don't cascade, so you don't get a spiraling, uncontrollable mess. And once an action goes into the store, you can't put another one in until the store has finished processing this action, so the dispatcher handled this by queuing up actions and dispatching them one at a time. So now I'm going to talk about how we separated the gameplay into 3 different components. First, we have the game client store. And this store handles all protocol level interactions. The game client store handles all communication between the web and the server through a WebSocket. For example, moving from the game intro into the first round of the game is the responsibility of the game client store. And all the actions that come into the game that aren't related to errors or game state changes, they are forwarded to the next store. So the game logic store is our second store. This store accepts commands or actions from the game client store that relate to a single round. So here we have a timing logic that plays a single round and updates all of our timers using data objects. This store handles decreasing the question timer, decide which answer to show, decide if we should show the correct answer, and keeping track of the in-game score, among other things. So this store handles pretty much everything you see on these screens here. And as I said before, this store doesn't handle any communications. Those all go through the game client. Therefore, we don't need any checks for error states in this store because they will surface in the client. And lastly but not least, we have the game results store. So what the game results store does is it listens to the game logic store, which forwards everything that you answer to this store. It forwards the answer time, score, question, and everything that relates to the results. We gather all this information about result-related things here and display it in the endgame scene as seen on the pictures. The way we construct this store is that it takes all of its information from the game logic store and it sets it up exactly like our server would send the data to us. This lets us reuse the store and the full endgame scene without any modifications when displaying the game history, where users can reopen old games and see the results. Constructing the data on the fly also enables us to use that data when displaying the endgame scene without waiting for the result object from the server. So by structuring the gameplay this way, we keep it in a unidirectional flow like the Flux is, and it makes it easier to track down bugs. We also have a separation of concerns this way by splitting different components of the game into different stores. So we know that if the score is wrong during a game, then it's a bug in the game logic, because that handles that. Same goes if the game crashes out of nowhere, we know it's a game client bug, and if you don't get your win bonus at the end of the game, it's a game result store fault. So when we started working on the gameplay, we figured out we have lots of timers in the game, and set timeout seemed like a good choice for that. So we have timers in places like how long do we wait for the player to read the question, And then we show one answer at a time over 400 milliseconds or something. And then we have a 10-second question timer. And we have a scene between questions that says like round 3 or something. And these are just some of the timers that we have. So set timeout, it made sense. When we released the 21st of May and started getting our bug report emails, we realized this was a bad idea. There are a lot of bugs in the gameplay being reported, and many of them were non-deterministic, and clearing of all of the timers had to happen in a lot of places. So the code was a mess. When you set a timer in the store, you're breaking the dispatcher model, because now there's a timer that can fire during another action that it shouldn't be allowed to. So how do you track down a bug if you don't know where it's produced? That's when we changed to request animation frame. Using request animation frame, we could use the stores to the fullest instead of relying on timers being set. This allowed us to create a time-based loop using date objects, which changes its functionality dependent on how long it's been since the question round started by simply doing date calculations. And all of the store updates, they're made instantly inside that loop. So if that makes the bugs much more deterministic than timeouts, because we know what part of the loop is running when the bug occurs. So we construct our stores that way that we want to keep all of the business logic inside the store. We don't do any business logic in the components, or at least we try not to. That makes each store has its own get function, and all the components fetch their data from the store. They never store anything internally unless it's just for this component. It doesn't store any data that is relevant for the whole application. The stores are easily testable because we can just simply fire an action and see if the get function returns the data we expected. And because of this, there's less need to write tests for the components, and it's tedious to write tests for HTML components. So their only job is to render the data that they're given, and we just watch the stores do the rest and test that part of the application. So lastly, I want to show you some of the tools that we've been using. We highly recommend all of them, but we especially want to point out Immutable.js. Immutability has saved us so many hours of debugging because JavaScript objects are stupid. You can mutate them, and they, don't know where they're mutated, so everything shit hits the fan. And if you're not using them already, we recommend that you try. After using it in the web client, we actually started using it just in all of our Node.js services that we have written since then. So I would highly recommend them. Also, I want to point out Babel. We use them in all of our Node.js projects now that we write from the day to day. ES6 is awesome. It makes the code much more beautiful, and it supports new functionality that is extremely helpful in many situations. So that's it. If you have any questions about how we use Flux, gameplay implementation, or any tools we're using, you can talk to me or Hugi or Sölvi. I don't think any other of my team is here. So feel free to find us, and any questions? All right. Oh, yes, and Thor asked me to put this up.
Awesome. I'm not going to say anything much. I just want to thank you all for coming out. It's a huge turnout, way, way, way more than we expected. But we're going to do it again in August. We already got one speaker. So we only need like a couple more. And if you want to speak, if you know somebody that could speak, just hit us up on GitHub. And thank you for coming. I believe Kristian's going to say something because he stands here menacingly.
Yeah, it's basically a wrap. You can stay as long as you want, I guess, until we're kicked out. So we can just move the chairs to the side and we can have a chat about JavaScript or just how good the weather has been or something. So thanks for coming.